Hello, Dr. G coming at you with another video. Today we're going to do one sample proportions and we're going to do it in Jamovi. Today though, I'm going to walk you through the entire 4-step process. So this video will be a little bit longer as we're going to focus on the entire process and just use Jamovi for the calculations. So the problem is the CW network believes that 34.8% of viewers watch The Flash. On March 28th, 2016, The Flash had a crossover episode with Supergirl. It was a great episode. I loved it. The network took a random sample of 350 viewers and found that 137 watched that particular show. What we want to know is, does this provide strong evidence that the proportion of viewers has increased? Okay. Step one would be to write the hypothesis. The hypothesis, the null hypothesis, is the standard quo. This is the no change hypothesis. If there's no change, we would expect the proportion to continue to be 3, 4, 8, right? The 34.8% converted to a proportion. And because it has increased, we're going to have greater than the 0.348. Those two numbers have to be the same. One is going to be equal and one is going to be greater than. Now that we have checked the assumptions, hypotheses, we can check the assumptions. So step 2 is to check those assumptions. For random, it actually tells us that it took a random sample, and so random is met. That would be a yes. Independent. Is it reasonable to assume that these 350 viewers, because they were selected at random, are going to be independent? There's not going to be some sort of inherent bias with the larger population. And because it's random, that's going to be yes. Usually you would be looking for something that would indicate a bias. And then less than 10% of the population. To use the normal distribution here, we need this to be less than 10% of the population. The thing that I actually do is I do 10 times the sample size and then see if that seems reasonable. And so if I multiply 350 by 10, I get 3,500, and there are certainly more than 3,500 people who watch a network show in prime time like The Flash. Finally, we have our success-failure condition. Now, we have to have at least 10 successes. We have 137 people who watched The Flash, so that is at least 10. And then the failure condition is going to be the 350 minus the 137 that watched it. So that's going to give us 213, and that is certainly greater than 10. So we have met both of those. I'm going to have a little aside right here. The success failure condition for proportions will differ from book to book. So please check with your statistics textbook, your instructor, to make sure that you are doing the sample size calculation that they want. But now that we've done this, we are ready to go into step 3, the calculations, and this is where we head over to Jamovi. And now we're in Jamovi. So what do? I'm in this data. So what I'm going to do is I'm going to set this up and I'm going to type in watch, or you know what, let's just call it, let's just call it count. Okay, we're just going to call it count. We're going to leave it as nominal, right? And we are going to put the 137 here and the 213 here. Okay, now this is the easiest way to do it. Now when I go over to analysis, I can go over to frequencies. I can go to the two outcomes binomial test for a one sample proportion. And what I can do is I can take that count and I can move it over because the Venn diagram matches in the corner. But I want to do the values are counts. And now what you'll see is instead of the levels being 137 and 213 with a count of one each, I can click on this and now I have two levels, and the first level is the 137 and the second level is the 213. I can see the proportions of watched and didn't watch, right? And then what I need to do is change this test value. This test value needs to be the 348 proportion. And then I need to change my hypothesis to greater than. And when I do that, I get a p-value of 0.504, which is slightly above my level of significance. And so I would not reject. I can go back here and then we can say at the 5% level of significance, we do not reject that the percentage of viewers of the flash is 34.8% because we do not have strong evidence. This is the easiest way to do it. Now, there is a beautiful way of doing it in the ESCI module. So in Jamovi, if you go over to the little plus modules and you select the Jamovi library, if you search for the ESCI, you can install it, which I have. And this is the estimation statistics with confidence intervals module. And it's super nice. And so if I go ahead and click on this, I want to go down to proportions, a single group. I don't have full data to analyze. I have summary data. And so I'm going to have the flash, and the affected is going to be watched, and then the not affected is going to be not watched. And I'm going to put the 137 here and the 213 here. And I am going to go ahead and do a hypothesis test. And my evaluation is I'm going to do it against 0.348. So now we go down here and the flash minus the reference value. We're looking at the reference value of 34.8%, and I have this 95% confidence interval. Here's the z-score, which is very nice. The p, though, is a two-tailed test, and it's 0.8, and so I have failed to reject, which is what we got. The 0.348 remains a plausible value at this. Now, this is actually doing a two-tail test. So what I need is I need 5% in the lower tail and I need 5% in the upper tail. So to make this a one-tail test at the 5% level of significance, I need to change the confidence interval to 90%. If I do that, I can see that now the 90% interval does not contain the null. I should reject because it is not a plausible value. And what you need to do is cut this in half. And so you would take the 0.853 and you would cut it in half and you would get 0.425. 427, right? 0427, okay? And we would reject that, all right? Which is a little different than what we got here from the other one. I think this is probably better. I would say we do reject. We do have strong evidence, and the evidence is because we have the 427 when I cut it in half and round to 4 decimal places. I'm not quite sure why Jamovi has one p-value for the two proportion test versus the single group proportion here. I like this a lot. And then if you want a bonus, this graph is really cool, but it is a little bit hard to read. And so what I'm going to do is I'm actually going to change it to go from 0.3 to 0.5. And by doing that, I get a much better picture of where the reference value is and where the confidence interval is. And so here is a really nice graph to put in a project. If you learn something about proportion tests, if you learn something about Jamovi, then that makes me happy, and I look forward to seeing you in the next video.